Right, I'm going to break this podcast into two parts. One of the reasons why is because this is such an intense equation. It's wonderful because it brings together everything you've learned in Unit 3, Unit 4, Unit 6, and now Unit 7. Oh my goodness, take a look at this. Holy moly, we got 1 over x squared plus x minus 6. So again, I'm going to take this and make it into two different ones. I'm going to show you how to graph the reciprocal function. I'm going to do this domain and range and the invariant points in the next podcast, but I'm definitely going to do the vertex here, okay? So we're going to have to do 2 podcasts to break this up. Now, let's start. First things first, always start with the original. This is x squared plus x minus 6. PSA this, you should be able to do this quite quickly now. This is going to be x plus 3, x minus 2. You know that this means x can equal to, minus 3 and 2. But the cool thing is, since this is now 1 over, right, these actually become non-permissible values. Look at that. Minus 3 and 2. They were critical points. That they become non-permissible values the second you put it as 1 over as a reciprocal function. So let's put this in. 1, 2, 3, there's minus 3. 1, 2, there's 2. They not only become your non-permissible values and critical points, but they also become your vertical asymptotes. You got it. So x equals to minus 3 and x equals to 2 become our vertical asymptotes. And I'm going to draw them in right now. Bada boom. And bada boom. Perfect. Okay. Now, the next thing here that we have to do is we know that this thing is going to be some sort of parabola. We know it's going to come through here like this. It's going to have a number going way up there. It's going to have this going way up here. But I'm curious, where is the vertex in all of this? And the vertex is actually quite easy to figure out. You could take this, complete the square, and find the vertex that way. Or because these are really, really pretty numbers. Look at this. This is plus 2. This, of course, is minus 3. Those are really, really pretty numbers. We can actually figure out the vertex, which we know is in the middle of these two things. So just count. 1, 2, 3, 4, 5. 5 divided by 2 is 2.5. So go from this point here and go 2.5. 1, 2.5 right here. So our vertex is at minus a half. There's our vertex. So we can figure out that being our vertex at minus a half, we can just plug that value back into our calculator. And let me clean this up here for you and let me show you what I mean here. Go back to the original equation, which was x squared plus x minus 6, and pop in a minus a half for each one of these. Look at that. If we pop in the value of a minus a half into each one of these, we can determine what that is. Throw that into your calculator. What you're going to find out, this actually works out to be minus 6.25. That's the value of your vertex, minus 6.25. Pop this in your calculator. If you don't believe me, throw that into your calculator. That's exactly what you're going to get. So on this then, at a negative a half, I can go down 1, 2, 3, 4, 5, 6.25. So about there, and that's what my equation should look like. There's where my graph comes in, down around here like this, and comes back up to here like that. Now, the cool thing that happens here is, what is the value of the vertex when it's reciprocated? Well, all you got to do is just put it over 1. Okay, so 1 over negative 6.25. 1 divided by negative 6.25 works out to be negative 0.16. There's your vertex of your reciprocal. So this becomes negative, oops, use the blue one here, negative 0.16. There's your vertex of your reciprocal function right there. Now, the cool thing also is then, remember your invariant points. Your invariant points happen when this particular graph right here comes through here, down here, and up through here. And if you look, invariant points happen when y equals to minus 1. So look, there's my invariant point. Looks like it's right about there. Look at my other invariant point right here at your y equals 2 minus 1. There it is, there and there. So graphing this guy now becomes really, really easy. You start at your vertex, you go through your invariant point and go down here like this. Start at your vertex, go through your invariant point and down there like that. There's the one portion of your graph. Now, your other portion of your graph is when you got your other invariant point, which is at plus 1. Now, granted, we're not giving the exact values of the invariant points. We'll do that in the next podcast. But what's cool here is this. Look, right here is the other invariant point. I'll use blue. There's the other invariant point right here. So you know that this is a graph going up in this direction here like this, which means you start here close to your non-permissible value, which of course is your asymptote, and you go out here and there. Perfect. Look at this. Here's your other invariant point right here at y equals to plus 1. This comes down here like this then, through that point and bends out this way. That's what your reciprocal graph will look like. Whew, what an amazing question. Stay tuned now for domain and range on this.